Okay, number 32. We have to use a double angle identity for cosine 2x to express cosine squared in terms of cosine 2x. Okay, so that's just going to be 2 cosine squared x minus 1. And we want to solve for cosine squared. So when we add 1 and divide by 2, so hence, yeah. So now I'm going to take out the 1/2, cosine 2x plus 1 dx. And cosines is sine 2x. And don't forget, we have to divide by 2 plus x, then plus c. And that's the answer. All right, if we want sine squared, we have to solve this one. And you think we've got sine squared plus cosine squared is 1. We can't use that. We need the squared to go away. But we can use cosine 2x equals 1 minus 2 sine squared x. So we are going to subtract 1, divide by -2. So that we have the integral of sine squared. I'm going to take the -1/2 out, and that's cosine 2x minus 1 dx. So -1/2, and this is going to be sine 2x divided by 2 minus x plus c. Okay, so use the double angle identity for sine 2x. So yeah, sine 2x for A, we have sine 2x equals 2 sine x cosine x. So if we divide by 2, we have what sine x cosine x is. So we can have 1/2 sine 2x dx, and then this is going to be negative cosine 2x divided by 2 plus c. So we're going to have -1/4 cosine 2x plus c. Okay, so for B, if we have, let's say 2 sine, okay, let's just do 2 sine theta cosine theta equals sine 2 theta, right? So in this case, what we have here is that theta is 5x. All right, so we have 2 sine 5x cosine 5x. So that's equal to sine 2 times 5x, which is 10x. And then we would divide by 2, that's an arrow, to get sine 5x cosine x by itself. So we have in B, that thing is equal to 1/2 sine 10x and dx. So then we can integrate. Sine is negative cosine 10x divided by 10 plus c. So we'll have -1/20 cosine 10x plus c. Okay, so this one, I'm going to separate it first. 3x over 2, 2 over 3x, and 2 cosine 2x over 3. Okay, so I'm going to take out a 3 over 2. I'm going to take out a 2 over 3. I'm going to take out a 2 over 3. And then this all looks very manageable. So we're going to have 3 over 2 x squared over 2 plus 2/3 natural log x plus 2/3 sine 2x over 2 plus c. So then we'll have 3/4 x squared plus 2/3 natural log x plus 2, those cancel, 1/3 sine 2x plus c. So for 45, this one kind of looks like one of those like the arctangent one, but we've got the x on the top, so that's not okay. So if we make u x squared plus 9, then we have du with respect to x is 2x, which means dx is du over 2x. So we can rewrite our integral as x over u du over 2x, which the x's cancel and we can take out the 1/2, and then it's just 1 over u du. So this is going to be 1/2 natural log u plus c, and we just have to resubstitute in u, which is x squared plus 9. And you don't need the absolute value because it's x squared plus 9, so it'll always be positive. Okay, so same thing here. We would make x squared plus 9 u, and then du dx is 2x. So dx is du over 2x. So our integral becomes x over u squared du over 2x. And those cancel. So we have 1/2 integral of u to the negative 2 du. So this, we would add 1, divide by that thing, plus c. So we have negative 1/2 u to the negative 1, which means u is on the bottom, and u is x squared plus 9 to the 1, and then plus c. Okay, so for this one, we can make you just kind of think ahead. If it's x squared plus sine x, then we're going to have the derivative is 2x plus cosine x, which cancels. So dx is going to be du over 2x plus cosine x. So we have our integral is 2x plus cosine x over u, and du over 2x plus cosine x. So that all cancels. So this is just 1 over u, which is natural log u, which is x squared plus sine x plus c. So that's A. B, if we have same u and dx, we're going to have 2x plus cosine x u cubed du over 2x plus cosine x. And then that's going to be u to the 4th over 4 plus c, which is x squared plus sine x over 4 plus c. Okay, 48. If we have, and then sometimes you have to just kind of trial and error. If it doesn't work the first time, figure out something else. So if we have e to the x plus 1, not the square root, because that's going to be chain rule, and it's not going to work, I don't think. So this is just going to be e to the x. So that means dx is going to be du over e to the x. So we have e to the x square root, which I'm going to write as 1/2 du over e to the x. So then we add 1, divide by that thing, plus c. So that's 2/3 e to the x plus 1 plus c. All right, so we have a function. We've got the second derivative of it. We've got a minimum Okay, so we need to integrate first of all, because we'll have the first derivative is the integral of the second derivative. And then, so we're going to have the integral of 2x minus 2 dx, and that's going to be x squared, because the 2's would cancel, minus 2x plus c. And we know there's a minimum, so that means at x equals 3, the first derivative 0. So we're going to have 0 equals 9 minus 6 plus c, so c ends up being negative 3. So we have the derivative is x squared minus 2x minus 3. So we have not finished that yet, because we have to now do the integral of the derivative. So that is going to be x squared minus 2x minus 3 dx. And that's going to be x cubed over 3 minus x squared minus 3x plus c. And we know that the minimum point is negative 7. Y is negative 7, x is 3. So that's 3 cubed, 27 over 3, 9, minus 9, minus 9 plus c. Those will cancel. Adding 9, we have c is 2. So that means f at x is 1/3 x cubed minus x squared minus 3x plus 2. All right, that's A. So B, f at 0 is 2. F at negative 1 is going to be negative 1/3 minus 1 plus 3 plus 2. So that's 5, 4, minus 1/3, so 3 and 2/3. And then f at negative 1, the derivative at negative 1, we're using this one. So that's 1 plus 2 minus 3, so 0. So that's a max or min there. So if we do the second derivative at negative 1, we can find whether it's a max or min. So we use this thing here. So that's negative 2 minus 2, so less than 0, concave down, max. All right, so we want to sketch the graph. Okay, so we have the point 0, 2. We have a max at negative 1, 3 and 2/3. And we have a minimum at 3, negative 7 down here. And so we're going to have something like that. Okay, 50. So we have this function with the second derivative. The graph has a minimum point and a maximum point at that ridiculous number. Use the second derivative to justify. Okay, so if we sub in negative 4/3, so 3 times negative 4/3 minus 1, so that's negative 5 less than 0, concave down, a max at x equals negative 4/3. Okay, so B, given that the derivative is that, show P is negative 4. Okay, so if we integrate the second derivative, we're going to have 3x squared over 2 minus x plus c, and then we have that this is the first derivative. So we know there is a minimum, we'll use the minimum, at x equals 2. So we know the first derivative is 0 at x equals 2. So 3 times 2 squared over 2 minus 2 plus c. So 12, so 6 minus 2 is 4, so C is -4, or P is -4. So we would have the first derivative is 3x squared over 2 minus x minus 4. Now if we want to find the original function, we have to integrate the first derivative. So we're going to have 3x cubed over 2 times 3 minus x squared over 2 minus 4x plus c. And this is the the original function. I'm going to cancel those. And I'm going to use 2, 4. So 2 cubed is 8 over 2, which is 4. Minus 4 over 2, 2. Minus 4 times 2, 8, plus c. So we're going to have the 4's will cancel. And that's -10, so c is +10. So we have the function is x cubed over 2 minus x squared over 2 minus 4x plus 10.